Good morning, students. Exercise 8.3, the problem number 6. Show that the vectors A vector is equal to 2i cap plus 3j cap plus 6k cap, and B vector is equal to 6i cap plus 2j cap minus 3k cap, and C vector is equal to 3i cap minus 6j cap plus 2k cap are mutually orthogonal. So we have to prove the three vectors are mutually orthogonal. That means we have to prove that if you consider A vector is perpendicular to B vector and C vector. The same way, if you consider B vector, means we have to prove that B vector is perpendicular to A vector and C vector. And C vector, if you consider C vector is perpendicular to A vector and B vector. Okay, so therefore, if we prove like this, we can say the three vectors are mutually orthogonal. So I have considered the three vectors here. I am going to find A dot B. Okay, so if any two vectors are perpendicular, the scalar triple product is equal to 0. So I'll consider A dot B. So how to find the dot product or scalar product? You have to multiply the same component, then add. So you take the coefficient of I cap in the first vector is 2. Here you are having 6. 6 2s are 12. You go for the same components of j. So that is here the coefficient of j cap is 3. Here the coefficient of j cap is 2. So 3 2s are 6. And take this number k cap coefficient is here in the first vector is 6. The second vector k cap coefficient is minus 3. If you multiply 6 into minus 3, that is minus 18. So 12 plus 6 is 18. 18 minus 18 is 0. So therefore A vector is perpendicular to B vector. And go for B vector dot C vector. So I have considered B vector and C vector. If you multiply, if you take the dot product between them, so 6 3s are 18. 2 into minus 6 is minus 12. Minus 3 into 2 is minus 6. So if you add all the results, it is 0. So therefore B vector is perpendicular to C vector. In the same way, go for C vector. C vector dot A vector you consider. What is it? C vector dot A vector. So C vector and A vector is written. So if you take the dot product, 3 2s are 6. Minus 6 into 3 is minus 18. 2 into 6 is 12. So if you add, it is 0. So therefore C vector is perpendicular to A vector. So from the result, we have proved, you see now, A vector, B vector and C vector are mutually orthogonal. So we are coming to the problem number 7. Okay, so show that the vectors, what is given? The vectors form a right angled triangle. Okay, so this word is very important. What is it? The vectors. What is it? The vectors. So vectors means we have to take first vector as A vector, second vector as B vector and third vector as C vector. So you have to prove that they form a right angle triangle. So in the previous exercise, we have seen how to find the given vectors or right angle triangle. So we'll consider the magnitude of A vector, magnitude of B vector and the magnitude of C vector. Using the magnitude, we verified the Pythagoras theorem. So if the Pythagoras theorem is verified, in the triangle one of the angle is 90 degrees. So therefore they form a right angle triangle in the previous exercise. Now you have learned the scalar product. Okay, so the dot product between any two vectors is 90 degree. That is dot product between the any two vectors is 0. Those two vectors are perpendicular. So the angle between them is 90 degree. So in both the way you can prove. See, the previous exercise method also you can go for it. And using the dot product, you can prove the vectors form a right angle triangle. So for that you have to do two steps. One step, you have to find some relation among the given vectors. See, if we add all the three vectors, it is 0 vector means they form a triangle. So these vectors form a triangle. Or any sum of any two vectors is a third vector. You can say these three vectors are form a triangle. First, you have to check whether the given three vectors form a triangle or not. That is the first step. For that, if you add all the three vectors, it is a zero vector, means the given vectors form a triangle. Or the sum of any two vectors is a third vector, means they also, the vectors form a triangle. So here I just add all the three vectors. You see that how to add all the three vectors, the same components has to be added. So here you are having -1, here it is 2, here it is -1. So -1 is -2, -2 plus 2 is, what is it, 0. So 0 I cap. Okay, and go for the j cap components added. -2 minus 1 is -3. -3 and plus 3 j cap is 0 j cap. And here -6 plus 1. What is it? -5 k cap. -5 k cap plus 5 k cap is 0 k cap. So therefore, the sum of all the vectors, sum of the three vectors is equal to 0 vectors. So therefore, the given vectors form a triangle. But our question, we have to prove that they form a right angle triangle. So here up to this we have proved they form a triangle. So in the triangle, any one of the angle is 90 degree. The triangle is a right angle triangle. So here I can consider B vector dot C vector. These two vectors I have considered. I have taken the dot product between them. So if I take the dot product, how to take the dot product? The same components alone has to be multiplied, then add. So 2 into -1 is -2. And take the coefficient of j cap, that is -1. -1 into 3 is -3. Here k cap coefficient is 1. Here you are having 5. 1 into 5 is 5. So if you add the numbers, it will become 0. So therefore, B vector is perpendicular to C vector. So the angle between B vector and C vector is 90 degree. So in the triangle, the one of the angle is 90 degree. So therefore, the given vectors form a right angle triangle. Okay, so we'll come to problem number 8. See, if modulus of A vector is equal to 5, modulus of B vector is equal to 6, and modulus of C vector is equal to 7, and A vector plus B vector plus C vector is equal to 0 vector. Find A dot B, that is A vector dot B vector plus B vector dot C vector plus C vector dot A vector. So the four results are given. You have to find this result. So I have considered first A vector plus B vector plus C vector is equal to 0 vector. So squaring on both the sides. So it is in the form of A vector plus B vector plus C vector the whole square. So we have to use the vector identity. So we have learned the vector identity, that is A vector plus B vector the whole square. How it will be written? Modulus of A vector the whole square. Otherwise you can write A square plus modulus of B vector the whole square plus 2 into A vector dot B vector. Okay, in the same way, what is A vector plus B vector plus C vector the whole square? If we have three vectors, how it will be written? Modulus of A vector the whole square plus modulus of B vector the whole square plus modulus of C vector the whole square plus 2 into A vector dot B vector plus 2bc we will write here, B vector dot C vector here plus 2 into C vector dot A vector. So from all the results, what is common? 2 is common. So therefore, if you take it out in the left side, you will get the result. What is it? Modulus of A vector the whole square plus modulus of B vector the whole square plus modulus of C vector the whole square plus 2 into A dot B, that is A vector dot B vector plus B vector dot C vector plus C vector dot A vector. It is equal to 0 vector the whole square. So if you any vector, the square of any vector, so we have learned A vector dot A vector, that is equal to modulus of A vector the whole square. So this is nothing but, what is a model? It's a number, so that is A square. Here 0 vector the whole square is there. That is 0 vector dot 0 vector. So the answer is, what is that? Modulus of 0 vector the whole square. What is modulus of 0 vector? It is 0. The magnitude of 0 vector is 0. So 0 the whole square is equal to 0. So therefore 0 vector the whole square is nothing but 0. So if you square any vector, you have to use the dot product between them. So the answer is a number. Okay. Modulus of A vector, what is given? 5. So it is 5 square. Modulus of B vector is 6. So it is 6 the whole square. Modulus of C vector is 7. So it is 7 the whole square. Plus 2 into, this is the result we have to find. It is equal to 0. So when you square it, it is 5 squared is 25 and 6 squared is 36 and 7 squared is 49. If you add all the result, it is 110. This 110 will go to the right side as minus 110. And this is the, what is the result is asked? A dot B plus B dot C. That is a plus C vector dot A vector is asked. So this 2, when you bring it to the right side, it come in the denominator. So minus 110 divided by 2, that is equal to minus 55. So we have found the result. And coming to the problem number 9, show that the points 2, minus 1, 3 and 4, 3, 1 and 3, 1, 2 are collinear. So this model problem also we have done in the previous exercise. Okay, so any here what is given first, show that the points, so which is given points. So points means we can write the position vector. Okay, we have learned in rectangular components, isn't it? So the 2-dimensional and 3-dimensional rectangular components, if any point is given, we can write the position vector. So the first point I have taken as A, so we can write OA vector. What is OA vector? 2i cap minus j cap plus 3k cap. So go to the second point. If you consider that is B, so you can write the position vector OB vector. OB vector is 4i cap plus 3j cap plus k cap. And go for the third point, that is C. Okay, if you consider the point as C, so we can write the position vector OC vector as 3i cap plus j cap plus 2k cap. So we have written the position vector of the points. We have to show that the points are collinear. So in the previous exercise, that is 8.2, we have learned any two vectors are collinear. You see that I am not using the position vectors. Any two vectors are collinear, that is A vector and B vector are collinear. How it will be collinear or parallel? Any two vectors are collinear means you can write one vector is a scalar multiple of other vector. If you can write, we can very well say these two vectors are collinear. Okay, so that result we have used in exercise 8.2. Now you have learned the scalar product. You see the procedure. Okay. You see now the position vectors are given. From that you have to find any two vectors. So one vector is AB vector, another one vector is BC vector. So AB vector, using position vector, how you can write? Position vector of the second point minus position vector of the first point. Okay, so here take the coefficients alone. OB vector coefficients is what it is? It is 4, 3, 1. And OA vector coefficient is, it is 2, minus 1, 3. So in between you are having subtraction. So you have to change the sign of OA coefficient. So it is minus. Here you will have plus and here you will have minus. Okay, 4 minus 2 is 2. 3 plus 1 is 4. And 1 minus 3 is minus 2. Okay, so therefore you have to write as a vector. So 2i cap plus 4j cap minus 2k cap. Then you have to find another vector, BC vector. So using position vector, how you can write? OC vector minus OB vector. So OC vector is first. So therefore OC vector coefficients you have to write. So what is the coefficient of OC vector? That is 2, 3, 1, 2. Next, which vector has to be written? OB vector. So the coefficient is what? 4, 3, 1. So in between what you are having? Subtraction. So it changes sign. Minus, minus, minus. So therefore it will be 3 minus 4 is minus 1. Here 1 minus 3 is minus 2. 2 minus 1 is 1. So you just coefficient we have taken and you have to write as a vector. So minus I cap minus 2j cap plus k cap. So we have found two vectors. If the previous exercise method also you can use. What is it? One vector is a scalar multiple of other. You consider your AB vector. From that if you take minus 2 out. So what is your AB vector now? Your AB vector is, what is your AB vector? Here 2i cap plus 4j cap and minus 2k cap. Okay, if you have from this, if you take minus 2 out, what has to come? Minus 2. I didn't take only 2, minus 2. So that is minus I cap. Here minus 2 is taken out. Now minus 2j cap. Minus 2 is taken out means it is k cap. So therefore minus 2 into, what is this? This is your BC vector. So here AB vector is a scalar multiple of BC vector. So and B is the common point. So therefore the vector, the points are collinear. In this way also we can conclude. Okay. So here using scalar product. Okay. How to prove the points are collinear. So I have considered the two vectors. I am going to find the angle between them. So what is the formula has to be used to find the angle between two vectors? You have to use cos theta is equal to A vector dot B vector divided by modulus of A vector modulus of B vector. So here your A vector is AB vector and your B vector is BC vector. So therefore cos theta is equal to AB vector dot BC vector divided by modulus of AB vector modulus of BC vector. And you have to take the dot product between them. So dot product or scalar product. How to take? You know that in the scalar product I cap dot I cap is 1, j cap dot j cap is 1 and k cap dot k cap is 1. So that's why we have to multiply the same components, then you have to add. Okay, so here the coefficient of I cap is 2. Here you are having minus 1. So 2 into minus 1 is minus 2. Only you have to write the number. You should not write as vector. Okay, and 4. Here the coefficient of j cap is 4. Here you are having minus 2. So 4 into minus 2 is minus 8. And minus 2 into 1 is minus 2. And how to take the modulus of AB vector? It is nothing but square root of 2 the whole squared. So it is 4. Take the coefficient of j cap 4. So 4 the whole squared is 16. And here minus 2 the whole squared is plus 4. In the same way modulus of BC vector also taken. So you have to take the coefficient square root of minus 1 the whole squared is 1 plus minus 2 the whole squared is 4 plus 1 the whole squared is 1. So here it is nothing but root 24. Here it is root 6. So when you add these numbers it is minus 12. So 24 can be written as 6 into 4. You see that what is square root of 4? Square root of 4 is 2. So square root of root 6 into square root of root 6 is 6. See now in the denominator this 24 can be written as square root of 24 can be written as 6 into 4. Okay, here you are having root 6. So square root of 4 is 2. So what is remaining here? Root 6. What is root 6 into root 6? That is 6. So therefore here in the denominator you will have minus 12 divided by square root of 4 is 2 and root 6 into root 6 is 6. So 6 2s are 12. So it is getting cancelled with the numerator 12. So the answer is minus 1. So minus 1 you can write in terms of cos as cos pi. So cos pi. So therefore theta is equal to 180 degree. Theta 180 degree means you see that one vector, that is AB vector. So what is it? AB vector direction like this and your BC vector. See now it will be like this. BC vector. So AB vector and BC vector, the angle between them is 180 degree. So therefore A, B, C, their 3 points are collinear. Okay, so see now the angle between the two vector AB vector and BC vector is 180 degree. So 180 degree means you see that they lie on the same line. A vector, A point, B point, C point, they lie on the same line. So therefore they are collinear. If angle theta is equal to 0 and theta is equal to pi means, so the points are collinear. They lie on the same line. So therefore the points are collinear. So we'll come to the problem number 10. See that if A vector, B vector are unit vectors and theta is the angle between them, show that sin theta by 2 is equal to half into modulus of A vector minus B vector. Second one, cos theta by 2 is equal to half into modulus of A vector plus B vector. And the third one, tan theta by 2 is equal to modulus of A vector minus B vector divided by modulus of A vector plus B vector. So what's the result is given? A vector and B vector are unit vectors. Unit vector means whose magnitude is 1. So therefore modulus of A vector, modulus of B vector, that is equal to 1. So you have to consider the first result. In that you take this alone, modulus of A vector minus B vector the whole square. So modulus of A vector minus B vector. So modulus of A vector the whole square, how we can write? This is nothing but A square, or we can write A vector the whole square. Otherwise you can go for A vector dot A vector. Okay. So here you are having, what is it? A vector minus B vector the whole square. So it can be written as A vector minus B vector the whole square. You can write like this. Okay, so you can use the vector identities. So therefore modulus of A vector the whole square plus modulus of B vector the whole square minus 2 into A vector dot B vector, and use the definition of scalar product. What is A vector dot B vector? Modulus of A vector, modulus of B vector, cos theta. So here they are unit vector, so therefore whose magnitude is 1. So 1 squared is 1. Here also 1. So modulus of B vector is 1. So 1 squared is 1. Minus 2 into, if you multiply 1 into 1 into 1, so 1 into 1 into cos theta, that is cos theta. What is 1 plus 1 if you add? That is 2. 2 minus 2 cos theta. If you take 2 out, what is remaining? 1 minus cos theta. What is it? 1 minus cos theta. Here you are going to use the trigonometry identity. So we know that what is it? 1 minus cos 2a, that is equal to 2 sin squared a. Okay, what is it? 1 minus cos 2a is equal to 2 sin squared a. So from this 1 minus cos a. So the angle is divided by 2. We have to write the submultiple angle. So therefore 2 into, here what is the angle? A. So a by 2. So 1 minus cos a is equal to 2 sin squared a by 2. Here what you are having? 1 minus cos theta. So 1 minus cos theta. In the place of a you are having theta. That is 2 sin squared theta by 2. So therefore 1 minus cos theta, using the trigonometry formula, it is written as 2 sin squared theta by 2. 2 2s are 4 and sin squared theta by 2. So if you take the square root on both the sides, what you will get? You will get modulus of A vector minus B vector is equal to, what is the square root of 4? It is 2. What is the square root of sin square theta by 2? It is sin theta by 2. So 2, when you bring it to the left side, it is 1 by 2 into modulus of A vector minus B vector. So first result we have proved. You come to the second subdivision. Here what you are having? Cos theta by 2 is equal to half into modulus of A vector plus B vector. So first you have to consider modulus of A vector plus B vector the whole square. So it can be written as a vector plus b vector the whole squared. So it can be using the vector identity, the same thing, modulus of a vector the whole square plus modulus of b vector the whole square plus 2 into a vector dot b vector. Use the definition of scalar triple product. What is that? A vector dot b vector, modulus of a vector, modulus of b vector, cos theta. And they are unit vector, so whose magnitude is 1. So modulus of a vector is what? 1. 1 squared is 1. Here also the same way, modulus of b vector is 1. So 1 squared is 1. So if you multiply 1 into cos theta, so that is cos theta. In the front you are having 2. So it is 2 cos theta. So what is 1 plus 1? It is 2 plus 2 cos theta. So if you take 2 out, it is 1 plus cos theta. So see that the previous, the same result, but in between you are having minus. So okay, here we know the identity 1 plus cos 2a, that is equal to 2 cos squared a. Okay, if you have plus, it is 2 cos squared a. If you have minus, you will have 2 sin squared a. So you have to be careful with the plus and minus. So if you write the submultiple angle, so the angle is divided by 2 means it is 2. 1 plus cos a is equal to 2 cos squared a by 2. So in the place of a you are having theta. So 1 plus cos theta is equal to 2 cos squared theta by 2. Okay, so here 1 plus cos theta can be written as 2 cos square theta by 2. 2 2s are 4. 4 cos square theta by 2. If you take square root, you will get modulus of a vector plus b vector is equal to 2 cos theta by 2. The 2, when you take it to the left side, it is 1 by 2 modulus of a vector plus b vector. Okay, you see now we have proved the second result and come to the third result. What is asked? Tan theta by 2. So from the first and the second we know sin theta by 2 and cos theta by 2. Using that result we are going to prove the tan theta by 2. How the tan theta by 2 can be written as sin theta by 2 by cos theta by 2. In the first subdivision, what is sin theta by 2? Half into modulus of a vector minus b vector. In the second subdivision, cos theta by 2 is half into modulus of a vector plus b vector. So you have to substitute that. So this half and half getting cancelled, you will get modulus of a vector minus b vector divided by modulus of a vector plus b vector. So we have proved the problem number 10. So we are coming to the next problem. What is it? Problem number 11. So let a vector, b vector, c vector be 3 vectors such that the modulus of a vector is 3, modulus of b vector is equal to 4 and modulus of c vector is equal to 5. So the magnitude of each vector is given and each one of them being perpendicular to the sum of other two. So each one of them being perpendicular to the sum of other two. So what is given? Each one of a vector, b vector, c vector are perpendicular to the sum of other two. If you consider a vector, so this a vector is perpendicular to the sum of b vector and c vector. So a vector is perpendicular to b vector plus c vector. So perpendicular means their dot product is equal to 0. So that's why I have written a vector dot b vector plus c vector is equal to 0. So it's a you see vector, that is scalar product is distributive over addition. So you can distribute the scalar product. So it is a dot b plus a dot c is equal to 0. If you consider b vector, your b vector is perpendicular to what? The other two, sum of other two vectors. So therefore c vector plus a vector. So they are perpendicular means the dot product is equal to 0. Then distribute the dot product over addition. You will get b vector dot c vector plus here b vector dot a vector is equal to 0. Dot product, that is a scalar product, is commutative. So therefore b vector dot a vector can be written as a vector dot b vector. Similarly, your c vector is perpendicular to the sum of A vector and B vector. So we can write C dot A plus C vector dot B vector is equal to 0. And you see that it's a dot product is commutative. So I can write this as A dot C, that is A vector dot C vector, plus B vector dot C vector is equal to 0. If we add all the results, you see now A vector dot B vector, here also you are having A vector dot B vector. But you are getting 2 into A vector dot B vector. In the same way, B vector dot C vector plus B vector dot C vector is 2 into B vector dot C vector. So A vector dot C vector plus A vector dot C vector, that is 2. So 2 into A vector dot C vector. So it is, from adding all the results in the 2, when you take it to the left side, right side, it will become 0 by 2, that is 0. So you are getting this result. Also, the magnitude of each vector is given. So what is asked? Find the modulus of A vector plus B vector plus C vector. You consider the square. So how it will be? Modulus of A vector the whole square can be written as A vector the whole square. So what I have said, modulus of A vector the whole square can be written as A vector the whole square. That is equal to A squared, that is equal to A vector dot A vector. So in the 4 ways we can write. So here I have taken modulus of A vector the whole square is equal to A vector the whole square. So here, so A vector plus B vector plus C vector the whole square. I am going to use the vector identity. So what is it? Modulus of A vector the whole square plus modulus of B vector the whole square plus modulus of C vector the whole square plus 2 into A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Okay, you see now. Here you have to substitute the modulus. Modulus of A vector is what? 3. So 3 squared is 9. And modulus of B vector is 4. So 4 squared is 16. Here modulus of C vector is 5. So 5 squared is 25. And we have proved that this result is 0. So the whole term will become 0. And if you add all the results, it is 50. That is 9 plus 16 is 25. 25 plus 25 is 50. So this is here, that is nothing but modulus of A vector plus B vector plus C vector the whole square. That only we have taken, and we arrived the result as 50. And what is asked? Only modulus of A vector plus B vector plus C vector. So you have to take the square root. So if you take the square root, it is root 50. So root 50 can be written as 25 into 2. Square root of 25 is 5. So 5 root 2 will be the answer. And coming to the problem number 12. So what is it? Find the projection of vector. Okay, I cap plus 3j cap plus 7k cap on the vector. So which word is important? On word is important. So first vector you have to take it as A vector and the second vector as B vector. So you know the formula. There is a geometrical meaning of scalar product. From that we have found the projection of A vector on B vector is A vector dot B vector divided by modulus of B vector. So after on, the word on, after that which vector comes, that should be written in the denominator. So here A vector, projection of A vector on B vector. So B vector comes after the word on. So it has to be written in the denominator. On the numerator you have to take the scalar product. How to take the scalar product? The same components has to be multiplied, so that, and then add. So here the coefficient of I cap in the first vector is 1. 1 into 2 is 2. Only you have to write the number. Here 3 into 6 is 18 plus 18. 7 into 3 is 21. So plus 21. How to find the modulus of B vector? You go for B vector and find the modulus. So it's a square root of, the coefficient has to be squared and then add. 2 squared is 4 plus 6 squared is 36 plus 3 squared is 9. So when you add, it is 41 divided by square root of 49. That is square root of 49 is 7. This is the projection of A vector on B vector. You see that here the 13th problem. Find lambda when the projection of A vector on B vector is 4 units. Here the projection is given. So what is given? The projection of A vector on B vector is 4 units. What's the formula has to be used to find the projection of A vector on B vector? A vector dot B vector divided by modulus of B vector. What is given in the problem? That projection is equal to 4. And find the dot product between them. Okay, so it is 2 lambda plus 1 into 6 is 6, 4 into 3 is 12, divided by modulus. If you write, that is a square root of 4 plus 36 plus 9. So that is 36 plus 4 is 40, 40 plus 9 is 49. Square root of 49 is 7. So if you add the numerator, it is 2 lambda plus 18 is equal to 4. 7 into 4 is 28. So 2 lambda plus 18 is equal to 28. Next one, 2 lambda is equal to 28 minus 18. What is 28 minus 18? It is 10. So lambda is equal to 5. So come to the 14th problem. 3 vectors A vector, B vector, C vector are such that modulus of A vector is equal to 2, modulus of B vector is equal to 3, modulus of C vector is equal to 4, and A vector plus B vector plus C vector is equal to 0 vector. The same model problem we have seen in this exercise. Okay, so find here what is given. 4 into A dot B plus 3 into B dot C plus 3 into C vector dot A vector is given. Okay, so first here take this result. This is the given result. Take that and keep what is it? A vector plus B vector in the left side and bring the C vector to next side. So squaring on both the sides and use the vector identities. Okay, so if you use the vector identities of this, modulus of A vector the whole square plus modulus of B vector the whole square plus 2 into A vector dot B vector. Here this can be written as, when you square, you will get modulus of C vector the whole square. And the modulus has to be substituted. Modulus of A vector is what? 2. So it is 2 squared. Plus modulus of B vector is 3. So it is 3 squared. Plus 2 into A vector dot B vector is equal to modulus of C vector is what? 4. 4 squared. So therefore here you are having 16. So 9 plus 4 is 13. 13 you bring it to the side, it is minus 13. So 16 minus 13 is 3. And bring this 2 to the denominator. So we have found A vector dot B vector is equal to 3 by 2. In the same way, what is asked here? B vector dot C vector. You consider the same result and B vector plus C vector is keep it on the left side. Bring this A vector to the next side. Then only you will get B vector dot C vector. See now. And use the vector identity, you will get this result and substitute the modulus, and you see that here you are having 4. So 9 plus 16 is 25. When you bring it to this side, it is minus 25. 4 minus 25 is minus 21. Bring this 2 to the denominator in the right side. So B vector dot C vector is equal to minus 21 by 2. Here you see that in the question, again what is asked? C vector dot A vector. But from the result, which vector has to be kept it in the left side? A vector plus C vector. Bring this B vector to the next side. So here I have written. So you have to squaring on both the sides, and when you square in this side you have to use the vector identity. So I have used the vector identity. What is it? C vector plus A vector the whole square. Modulus of C vector the whole square plus modulus of A vector the whole square plus 2 into C vector dot A vector is equal to modulus of B vector the whole square, and the modulus is substituted. So here modulus of B vector is 3. So 3 squared is 9. Okay, here 16 plus 4, what it is? 20. Bring this 20 to the next side. So 9 minus 20. What is 9 minus 20? That is minus 11. So when you bring this 2 to the right side, it will come in the denominator. So C vector dot A vector is equal to minus 11 by 2. So what we have found? A vector dot B vector, what it is? B vector dot C vector and C vector dot A vector. You consider the result, what is asked? This result. Okay, you take that result and in the place of A dot B you have to substitute 3 by 2. So it is substituted. What is B dot C? So we have found B dot C as minus 21 by 2. So in the place of B dot C it is substituted minus 21 by 2. What is C vector dot A vector? That is minus 11 by 2. So it is substituted. And if you multiply 12 by 2, here minus 63 by 2 minus 33 by 2. So in the denominator if you take 2, so here 12 minus 63 minus 33. So it is 12 minus, if you add these two, because they are having the same sign, so if you add it is minus 96. 12 minus 96 is minus 84 by 2. That is minus 42. So the answer for this answer is minus 42. Thank you, students.